Hi guys, welcome back to another video. So in this video, what I'm going to be showing you is how to find a quadratic rule from a value of tables. Now, what I've done here is I've used some examples from the Sadler textbook. So if you would like to follow through on that textbook, if you've got it, please do. Otherwise, you can just look at the screen. It's right here. I'm going to explain a few things. It is a bit confusing at first, but I think as you kind of go through a few examples, it does seem to make sense over time. Okay, so let's have a look here. It is important to note that we can find a gradient of a straight line by finding a constant difference pattern in y as x goes up by 1. So what I mean by that is usually, for example, for a linear one, I could have a values table like this, and I'd have, for example, if I keep going here. So this could be a linear. I know that because I will look at my constant difference pattern here, and I would notice that it goes up by 2. Now that constant difference pattern indicates that it's linear and tells me my gradient is equal to 2. And then I could work out what my y-intercept is and go back 1 and take 2 away, and to find that my intercept is going to be 1. So for example, this line here would equal 2x take take plus 1. Okay, so that's generally what you might have seen before, and that's not what this is about, but it's kind of like an introduction for you, because you might have seen a similar concept before where you're looking for a constant difference pattern for a linear question, and then usually use that information given to you in that table to find the rule. Okay, so that's probably something that you've seen before. Now, for quadratic functions, you actually have a constant second difference pattern. So I've got two tables on here at the moment. So you can see my first table is almost like a template. So for all quadratic equations, you're going to have a certain pattern that it follows. Okay, so if this is the rule here, y equals ax squared plus bx plus c, we can work out what a, b, and c is from our given table. Now, I like to focus on a few things. I like to focus on this one in particular. This box here, so for whenever x equals 1, what does y equal? And focus on this one here. And a few other ones can help you out eventually as well, and to help you kind of work out a few missing pieces. And I'll get to that in a minute, but these are the ones I like to remember. And right now it might not make sense, but I promise it will. Okay, so the best way I find to actually go through a question like this is to actually go through a values table example and actually to show you what I mean. Okay, so let's look at this example here. This is straight from the textbook here. So let's consider the following table of values with the first and second difference pattern showed. So usually you won't be given these difference patterns, and I might ask you to find the difference pattern or to determine whether or not it's linear or not. So for this particular example, I've shown you, the textbook's showing you the difference pattern. So this first difference pattern here is showing you that the difference between, it's a highlighter. The difference between these two numbers is 5, the difference between these two is 9, difference between these, and so forth. So that's your first difference pattern. But what they've shown here is that with the second difference pattern, it constantly goes up by 4. And because it constantly goes up by 4 like this in the second difference pattern, that's enough proof to show that this values table definitely shows a graph that is quadratic or a parabola shape. So generally when you're given these values tables, you're basically trying to find the rule, the quadratic rule from the table. Okay, so we're going to use this values table as well as our little template that we've got here to work out what the rule is. Okay, so I've got a few things that I want you to note here as well, a few little important things. Okay, so like I just mentioned, the constant second difference pattern confirms that it's quadratic. Okay, so like I just mentioned, because that is a constantly going up by 4, that's quadratic. Okay, now what we're going to do is we're going to use these numbers to find out what the quadratic rule is. So here it says, comparing the constant second difference pattern of 4 with 2a, the constant second difference pattern in the table for the generic quadratic gives us that a equals 2. Now, all that really means is, do we see up here that whenever we have a second difference pattern is equal to 2a, whatever that number is equal to 2a. And this a is that a. As in, we can use that number to help us figure out what a is, or the coefficient of the x squared in our rule. So essentially, if I have here 4 is equal to 2a, that means a is equal to 4 divided by 2, because I've just divided by 2 here, so that way I can get a on its own. So then a is equal to 2. So at the moment, my current rule is this. Okay, so we're going to see if we can use the rest of the notes to find out what b and c are, to find my final rule. Okay, so from the table of the general quadratic, we can see that when x equals 0, y equals c, because that y-intercept is always the case for when x equals 0. So when I look at my coordinates, I can see right here that my intercept is going to be -4. And that's the same as c, because if we go up here, this c is the same as this right here. So I'm going to go in my notes here, I'm going to go, well, if when x equals 0, y equals -4, also I changed pencil there, that's okay. So y is equal to 2x squared plus bx take 4. So far I've worked out what these two bits are, and now I'm going to work out this b. Now the way I like to work it out is using that coordinate that I mentioned before. So I like to use this here. So when I have x equals 1, my y coordinate is going to be equal to a plus b plus c. Here. Alright, so for this particular example, when x equals 1, my y coordinate is 1. So, and that is equal to a plus b plus c. So a plus b plus c is equal to 1. Now I just worked out what a is, and I worked out what c is. Right? So I'm going to use those two values and put it into here and rearrange for for b. So I'm going to put in 2 plus b take 4 is equal to 1. So then I'm going to have 2 take 4 is going to be -2. So I'm going to have b take 2 equals 1. Put this on the other side by adding 2. So b is equal to 3. So therefore my final rule is y equals 2x squared plus 3x take 4. Alright. Now, I'm going to stop the video now. I'm going to make another part to kind of show you another example without all this kind of notes, and show you how it would go if you had to work out the difference patterns individually on its own. So go check out that video straight after this one.